I've decided to just do 2 lectures while I'm gone, so this is the first of 2, today we're going to talk about using Python in ArcGIS. We're going to couple ArcGIS and Python together. And so in the lecture notes, I have a little bit of a review of the concepts, and I'm not going to be able to do that. I'm going to skip that in the interest of time, and we can talk about that a little bit when I get back. So we're going to dive right into using ArcGIS in Python. And first thing I'm going to do is switch to show you my screen and talk about a few things. So I'll do that. All right, so now you can see my screen here. You should be able to see my screen here. And this is ArcGIS, and these are the data sets we're going to use today. But before I even get to that, I'm going to bring up my the course webpage and discuss a few things. So here's the here's the course website, and you can see if you go to week 5, which is where we are, and you should see. Make sure I uploaded it. Oops, just a second. I need to upload it. Hold on here. There we go. Delete. I need to delete that. There we go. Okay, so I'm going to upload the current version. Master. Let's go ahead and sync that. There we go. All right, so we're all set. That took a few seconds there. Okay, so you'll see that now I've changed the data a little bit. As soon as it's go, there we go. So change the data, change the assignment a fair bit. We're going to do a simple assignment. Last year I jumped right in and I tried to do a pretty complex GIS task as the first assignment, assuming that most people had a strong GIS background. I think that a lot of people in the course last year thought that anyway, they got caught up in how difficult the GIS aspect was, and it made them hard to understand what was going on in the Python process. And so this year we're going to do a very simple task. We're basically just going to do an overlay and a couple of field calculations as part of our task. And the reason that we're doing that is to make it simple and straightforward, so that it's not a very complex GIS task. In reality, if it was a simple task, it might not be a good candidate for scripting, because one of the great things that we can do with scripting, and one of the reasons why we're scripting operations, is that it's a more complex task. However, this task is just complex enough that it is something that you might want to do over and over again. So it might help to have it be a script. All right. So we'll get to that as we proceed through. I am going to introduce the concept quickly, and it will be helpful for you to read these materials that I've provided here. So there's a book from there's a book chapter from an ESRI book that you can check out. Okay, this is ESRI's. This is ESRI's book that they've published on the topic that we're going to discuss today. It's running Python from ArcGIS. There are just the help files for Python. You can see those here. So this talks about what geoprocessing is. You should have done some geoprocessing in one of your other classes. If not, First of all, what do I mean by geoprocessing? It means running tools in our toolbox when we're talking about ArcGIS. Geoprocessing means running these tools. Okay, so I'm sure that many of you have done that. If not, read up on this web page and you'll get more information on that. A little bit of background on Python in general, and finally, what we're going to talk about today, which is the ArcPy module. We've discussed several times the different modules that are available in Python, both as part of the Python package. Those are included modules like math, and some additional modules that are third-party modules. ArcPy is basically a third-party module for doing ArcGIS operations. Now, if you're sitting at a computer where I've installed ArcGIS or you've installed ArcGIS, Python should already be available to you, and you can test that in a few ways. Okay, let's talk about running Python and ArcGIS. One thing that you could do is you can have under, let's see, Windows. Where is that? Under the geoprocessing, maybe it's under geoprocessing here. Yep, under geoprocessing, there is a window. I was looking for under Windows. There's a window called Python. You can click that, and so we have what looks to be, and it is, basically a Python interpreter right here inside of ArcGIS. Now, this is just an interpreter window. It can't be used for writing scripts, but we could use this for doing something like an overlay between census tracts and watersheds. If we just wanted to do an overlay, we could do that. We can say ArcPy. ArcPy is the name of the module, and then you have to type dot, and then you have basically any tool that's available in the toolbox available to you to run here. And so the name of the tool that I'm going to run is called Union, and Union has a few different versions. The one that I want to run is the default version that's in the analysis tools up here. This is the one that you'd run if you wanted to do just a regular Union overlay, which means that we're going to overlay these two data sets, and they will they basically break apart at the boundaries and form new polygons. Okay, you'll see what I mean in a second here. So I'm going to hit Union Analysis, and then I can type in the name of the feature. Notice that it prompts me for them. I can say census tract, comma, or census tracts. So it looks like I need to put these in as a Python list. So census tracts, comma, watersheds. Oh, they're separated by, I can look at the help here. They're separated by semicolons here. So if I say census tracts, semicolon, I don't know why it's not prompting me for the second one. Watersheds, now I say comma, and the feature class that I want to save this as, I can put it anywhere. So here I have to come up with a path location that I want to put the output file. I'm going to copy that from my computer here. Let's see, I'm going to go to ctemp lab data. Oh, by the way, I took the data from the course website. I downloaded and I copied it into this location, dtemp spa labdata.gdb. and then I brought it up in ArcGIS. I just, to save time, I didn't do that on screen. Okay, so I'm copying this path so that when I run, I'll have a union analysis output in that same location. Okay, so I'm going to do that thing where I write R and copy the path. Okay, R, remember what R does is it basically tells a string to ignore special characters like slashes. So I'm going to call this file tracks watershed. I'll just call it tracks watersheds. I'm going to call it tracks watersheds union. Okay. And I have to close the parentheses. So this is basically a function. We'll run this inside of a script window too, because ultimately that's what we want to do. But I've got now the syntax for running really any tool, but I'm using the union. I'm doing a union, and I'm unioning C tracks and watersheds, and I'm creating this as my output file. Okay. Now there are some other options in union, so I could hit column. The next option is join attributes, but I'm going to leave all those as defaults. Those later files, those later options are not required. They're optional. All right, I'm going to hit enter here. Oh, invalid syntax. Let's see here. What did I do? All right. What I'm going to do is look and see what I did wrong. Under union, I can go to any tool, and I can go under tool help, and it will provide a Python example for every tool that's in ArcGIS. And so I have here the example, and it looks like it does want these features in a Python list rather than a semicolon list like I thought that it wanted. And so in order to do this, what I'm going to do is first create a Python list. Remember how to create a Python list is with a bracket. So we could say layers is the name of a variable, equals, and then we use the bracket, and we could put in the names of the two layers that I want to interact with. There we go. So now this is a simple Python list. Let's see if it takes this a little bit better. All right, it's running. You can tell it now. It says it's executing. And this is the result. You can see that it ran the union analysis, and you can see now this is the result. This layer was the watersheds, and that layer was the census tracts. So the census tracts and the watershed layers have now been combined together, and the resulting layer has all of the attributes of both data sets. So it has the attributes that came from the census layer and the attributes that came from the watersheds. You notice that there are some areas right here, these areas, where there were no watersheds in those locations, and that's fine. So the census tracts are slightly larger in some cases, and actually in some cases where the watershed goes into Alabama, we don't have, or Louisiana, we don't have any census tracts in those areas. Okay. So we've got some overlay. We've got some areas where only one of the two inputs were present. In fact, what we probably want to end up running for the lab data is the intersection. So I'm going to write and rerun this tool, but instead of using a union, I'm going to use intersect. Rerun this tool, but now I'm saving the file as tracks watersheds intersect, and I'm calling the tool intersect analysis. Okay. I'm calling the tool, meaning I'm calling the function for that tool. So hit enter. I'm going to turn off the union to show you what this does. Okay. So this is a little review for those of you who've taken a GIS course before. But now, when we show the intersect, it only shows those areas in common to both it only shows those areas in common to both data sets, to both the census tracts and the watershed layer. So we can look at it, and actually for any particular area, it has the exact same attributes. So for this one right here, if I hit this and I do all layers, turn off watersheds, not all layers, visible layers. So now I hit this guy right here, and I've got two of the exact same polygon. One's in the union layer, one's in the intersect layer. The difference between the union and intersect layer is only the extent of the polygons. It's not the individual attributes or the shape of the polygons that are included in both data sets. Okay. All right. So we have our data set here, and we've run it using the interpreter window inside of ArcGIS. Now, I don't find myself using the Python interpreter window that much. I think it's just as easy to find the tool up in our toolbox and run it that way. Okay. However, if you have a process that you want to semi-automate, you could take your, let's say you wanted to do an intersect between lots of different data sets. You could copy and paste this command into a notepad window and change it slightly, and then just copy and paste. That might be faster. But again, I don't find using the interpreter window that useful unless I need to do some debugging or figuring out what's wrong with something. Most of the time, I use the script window to do these same sort of activities. All right, so I'm going to close up the Python window, and I'm actually going to remove my tracks watershed intersect and my tracks watershed union. I'm just going to remove those. So I have the watersheds in the census tracts, and I'll show how to run the exact same thing from a script. To do that, we do need to open the Python IDLE. Okay. So I'm opening Python IDLE. Okay. I'm going to leave ArcGIS up in the background. I should probably make this better. Let's see, bigger. See if I can make the text. Yeah, I can make the text bigger. Looks a little bit better. Okay, so then I'm going to open up this is an interpreter window, so I'm going to open up a new file. So I'll have a script window, and I'm going to type in import ArcPy. That's what I need to do first. I need to do that before I do anything else in order to get all of the functionality that's available in ArcGIS into Python. So before I do anything else, I'm going to save this. I am going to save this into the directory for the course so that I can upload it. So So I think I have that under D, courses, SPA, and week 5. And I'm going to call this 2016 example. The previous year's examples won't be very helpful in this one because they might be a little bit helpful, but we had a much different project, as I already mentioned. Okay, so 2016 example 1. Save this. Now I'm going to run this, and it's going to run. And notice that it took a few seconds. I don't know if you saw that, but I'll run it one more time. 1, 2, 3, 4, 5, 6, 7. 7 seconds. It took 7 seconds just to. If I took this import Python out and run the module again, it finished instantly. Okay. All right. Why does it take 7 seconds? And is that interesting? Well, it is interesting. When you import ArcPy, it is very much like you're starting up ArcMap. You can think of it as an analogous process to starting up ArcMap. It's only that the graphical user interface is not present. So it does take a few seconds to do that every time. You take a little bit of a performance hit when you do that. All right, so now let's practice utilizing running a tool from Python. So I'm going to go over to the Union tool, and I'm going to copy again. Go under Union Tool Help. I'm going to copy the example. I almost always just copy the example that's in the Python code sample in the help. It's just much faster than typing everything. I'm a horrible speller. Okay, so I'm gonna copy this and take it back over to Python and copy that in there. So notice that there are some additional parameters. In fact, we can go back to the help and look what all the parameters mean. So we've got in features, out feature class, join attributes, cluster tolerance, gaps. Okay, these aren't really important. They're optional. Well, not that they're not important. I mean, they're useful for some applications, but basically we could tell it which attributes we want to carry through. We can tell it what the cluster tolerance is, in other words, the minimum distance separating the features, and finally whether we want gaps to be present. In other words, if we had like a shape like Michigan and we overlaid it with a boundary of the United States that included the water boundaries, there might be some gaps there. Okay. Let's look here. So these are the two parameters that we're concerned about. So let's go ahead and delete or remove those parameters that we're not concerned about. These two. So we have the in features and the out features. And remember that it wanted the in features to be a Python list, and it wanted the out feature to just be a path or a string to the location where we want to store the output data set. And so I need to set up a list for my in features. In features equals, remember last time I was able to just type C, tracks, and watersheds. Right? Remember I was able to do that? Well, this is running ArcGIS, but it's a different copy of ArcGIS. In other words, you haven't loaded C tracks or watersheds into the view. In fact, there's no concept of a view or a data frame when you're using Python. So you either have to explicitly give it the whole path, in other words, the whole path to C tracks, which we can find. You find that here by saying properties and choosing the entire path. You could do something like this. That's where I stored C tracks. Put R in front of it again. Do the same thing for watershed. that's the location to the census tracts. That's the location to the watersheds. Okay. So this will work. We could also do what we call set up the environmental variable. Okay. The environmental variable is actually available in ArcGIS as well. And you can go in here and say geoprocessing environments and say, okay, I want my workspace to be in a certain location. And what that does is it makes it so that you do not have to when you go to hit add data, it takes you right to that workspace. Or anytime when you're using it in a geoprocessing tool, you don't have to type the entire front end of that data set. Okay, so I'll do that in a second, but first I'll demonstrate this this method. Okay, and so finally we want our output features to equal, let's see, make sure I'm spelling that, yeah, to equal something like this. And we'll call this, I'll just call it TW union. All right. So it's saving the output to this location. These are the inputs. All right, now I'm ready to run this tool. I'm going to hit run. Okay, hit OK. Oops. Oh, I put a parenthesis at the end, but I didn't put a parenthesis at the beginning. No problem. Run it again. Move this over here. All right, so it's running. In reality, or in practice, if you're running multiple tools, oftentimes it's helpful to report to the user what tool you're running. So you could put a print statement right before each tool that you run, say running union analysis. And that way it would be reported over here. I'll put that in there for next time it runs. Right, you could even put another print statement down here that says finished. Right. Okay, anyway, that finished. You'll see this next time it runs. So we could add this to ArcGIS. In fact, I'm doing that, right? I did that right now. I'm going to color a different color so we get the idea. All right. So we've got this pink layer represents the analysis that we just ran, or the tool that we just ran inside of the Python programming window. Okay. So now I can delete this guy, right, and go back here and run it again. Before I run it again, I want to show the concept of an environmental variable. So you could say arcpy.env. I'm going to make sure that I look up the help on this because I can't spell. Python's case sensitive. So I'm going to say ArcGIS Python environmental variables. There we go. Oh, this is 10, but it doesn't matter too much. Okay, so it looks like there's a one called workspace, env.workspace. You can either import the whole environmental variable or do what I did and say arcpy.env. So it's just called workspace. All right. So arcpy.env.workspace equals, and we give it this whole name right here. Now we do not need to include anything except for the name of the data set when we do an analysis. See that? So I just have tracks, watersheds, union. In fact, we don't even need the little R's in front anymore because all those do is tell it to ignore special characters. And when we're only talking about the name of a data set, we don't have to have a special character in front of it. I mean, we don't have to tell it not to. We don't have to. We do not have to tell it to ignore special characters. Okay, now if I run this right now, I'm going to go ahead and run it right now, but I'm going to get an error because by default, the environmental parameter that allows me to overwrite outputs is not, so it says union already exists. So I get an error there because I can go up into ArcGIS and say geoprocessing options and check this overwrite the outputs of geoprocessing operation. Well, I need to do the equivalent of that inside of ArcGIS. I need to do that same thing, and that's also an environmental variable. So this one, I definitely need to make sure I spell correctly. So if I say ArcPy overwrite output, I always forget whether it's overwrite output or overwrite outputs. But here we go. It looks like it is overwrite output, but it does have a capital O. So you can go in here and say arcpy.env.overwrite output equals true. And remember, the true needs to be capitalized. Python wants that true to be capitalized. Now I can run it again, and I won't get that error. Okay. So, and you see the message that popped up. Running union analysis finished. Okay. I can bring that layer back up. It won't be exciting because it'll look the same. Okay. So now it looks the same as the other layer that we created last time. All right. So now that we've run one tool in ArcGIS and we've used an environmental variable, actually we've used two different environmental variables, workspace and overwrite output, we can start to talk about what we need to do in today's lab. Okay, let's go to the GitHub SPA site, week 5. Okay, we covered all this. I am going to go down to the lab in just a second here. We've talked about importing ArcPy. Talked about using tools. We haven't really shown them inside of a function yet, but we could. You can utilize these tools inside of a function as well as outside of a function. So we might not get to that example today because we're going to write a rather simple script. So we might not need a function. Environmental options, we've talked about that. We talked about overwrite output, but there are lots of environmental options. There's things like setting the default cell size for processing, the default extent, some things I haven't listed here like the default spatial reference coordinate system. And I forgot to mention describe. Describe is a good tool for getting information about a layer into Python. It's kind of like hitting the properties button. Like, let's say we go over here and we say properties, and we get information about the layer itself. See all this information. We get information about the fields. Okay. We could do describe. I'll do that here in this price window. Let's Python. So I could say I'm just going to call it D in sense for describe equals arcpy dot describe. This is a built-in function. I gotta spell it right. This is a built-in function. It's not a tool, but you do feed it a layer. So I'm going to feed it the census tracts layer. Oops, I have to put that in quotes. It's a string, C tracks. And then I can run that. And now if I print D, it's going to tell me that it's an object. So this is an object. Remember, like we practiced last week dealing with objects. So it's a geoprocessing describe object. But that object has certain properties associated with it. We have to look at the help to see what those are, but they can be useful. So if I go into here and say ArcGIS Python describe, we can look at the help okay, and see that if we're asking it to describe certain things, we're going to get certain properties. We've asked it to describe a feature class. A feature class is ArcGIS's way of saying a data layer. So these are all of the properties that are available in your in a feature class. So we can say something like shape type is one of the properties. So we could say D dot shape type, and it tells us that it's a polygon. Okay. Why would this be important? Well, I know that I'm not talking to you live right now, but if you think about, let's say we're running a Python script and we wanted to be able to check whether the user had given us a point, line, or polygon layer because we're going to do something different. We could do that. We could say, okay, well, the user could say, here's the layer I want you to run. And then we could check to see whether it was a point, line, or polygon layer using an if statement. If it equals a polygon, then do this, calculate the area. If it equals a polyline, do something like calculate the perimeter. And if it equals points, then just count the number of points. That's an example of something that we could do. Now, this seems rather limited. There are other things that we want to know about a feature class. We've got shape type, shape field name. What about the fields? Okay. Well, one thing is that a feature class is also a table. Okay. And so a table does have that property fields. So we can say print d dot fields, and what we find is that the field object, the describe object contains in its fields property a list of more field objects. Those are objects themselves. What I could do is say f equals d dot fields, and then say print f. How do I get the very first field? I could say print f0 dot name. Okay, so that's the object ID. So I could get any of the fields. So I can get 4 dot name, and that's the population field. Okay. So the fields themselves are a list of field objects. If you click this button, field objects, or click that link, it will take you and show you all the attributes of the field object. One of them is name. That's the one I was using. We could find out what type it is, if it's a float, if it's a double. We could find out. We've got it, some code snippets here. All right, so let's progress to the lab. I think we covered everything that we need to cover there. Oh, there we go. That's the one we need. Okay, so that's the describe object. We're not really going to use describe. Maybe I can find a way to work it into the lab today, but we'll use that later when we do write more complex scripts where we ask where we need to ask it whether it's a point or a line or a polygon, or we need to know what the fields are. That's actually a pretty common exercise. All right, so this is our task for today. We have the census data and the watershed data. What we want to know is how many people live in each watershed. Simply put, that's all we need. That's all the information that we need. Okay, so how do we do that in ArcGIS? Well, that's really a GIS question, not a Python question. But let's take a moment to discuss how that could be done, right? So to do that, I'm going to go inside. I'm going to go back over to ArcGIS and look at the attributes. I'm also going to get rid of the union. Okay. So here's all my watersheds. I don't really need, it doesn't really matter to me what the attributes of the watershed are, except for I need a unique way to report. So I need a unique identifier field. Either the object ID or this HUC8 field will work just fine for that. So I want to know how many Mississippians live in each of these HUCs. They're watersheds. They're hydrologic units. Okay, so I want to know how many people live in each one. So at the end of this lab, I want to know what the population of each. I want to have 1, 2, 3, 4, 5 new population values. Okay. However, one thing I'm going to do is resymbolize the watersheds here. I'm going to no fill color, and I'll make these red. Okay. However, my population data is for Mississippi is contained in these census tracts. Now you'll notice that like this watershed here bisects this census tract. See this census tract? I've got half of it, roughly half of it in this watershed and roughly half of it in this watershed. Okay, same with this census tract. Okay. This let's see, this census tract right here is partially in no watershed, little teeny bit in this watershed, and a little teeny bit over, well, a bigger but still small version or portion in this watershed. Okay. So what we need to do is to allocate the number of people in each census tract to the watershed that they are inside of. But what we're going to do is assume that the people are kind of evenly distributed across the census tract, and we're going to calculate the area of each census tract that's within each watershed. Okay. In order to do this, let's open up. I'm going to open up the census tract. So we do have this layer called population. We also have this field called shape area. Now shape area get recalculated each time. So we need to create a new field and store the shape area, because what we need to do is figure out the area of each census tract before we do the intersect, and then the area of each census tract after we do the intersect. So the first step that I want to do is take census tracts and add a new field called area. We'll call it area, and we'll just calculate the shape area into area. Okay. All right, so let's do this inside of Python. So let's just, first of all, save this as 2016 Raber 5_1.py. All right. I'm going to save that. I'm going to delete this part. The rest of this I'm going to leave the same. And I need to go over here and find the tool for adding a new field. So if we go over to search, we can find the tool. I'm just going to type in add field. Oops, add field, that's not it. It's the second one, add field data management. I'm going to hit tool help. and scroll down and copy the example here. Now, I need to make a field that is a floating point field, so I'll have to change the syntax a little bit. I don't really need any of this other information, any of this information, because that's just optional stuff. So my end feature is going to be what? What field do I need? I want to calculate the area of the C-Tracks data set. So that's going to be my input feature. Okay. My field name that I'm going to add is called area. I'm just going to call it area. And instead of a long, it's going to be a double. Okay. I'm going to run this real quick. And I'm going to probably get an error. Hopefully not. I think that they fixed this in ArcGIS, but I'm not sure. Nope. Okay. In some situations, you can utilize a layer that's being utilized. You can't currently do this. So if I try to run this inside of Python, it gives me an error that says this data set's being used by another application. So I can't add the field area to census tract without first closing ArcGIS, which is unfortunate. Okay. So one thing that I like to do instead is open up our catalog, because in our catalog I can still get to the help. But I don't have to have the data set open. All right, so now our catalog is open. I'm just going to minimize it and try to run this again. And it should run this time. And it did. All right. Now, let's see what happens if I try to run it again, because I'm going to run this over and over a few times. And I just want to make sure that it's not going to get mad that I'm adding a field that already exists. It looks like it has no problem at all about that. All right, so let's look at the data set. So I have this saved in D, temp, SPA. You might have it in a different place. And I'm going to go ahead and delete these other data sets that we created kind of as temporary data sets, example data sets. So I'm going to look at the census tract, and I'm going to preview the table. And notice that now I have this field called area. And I need to calculate the shape area into that area field. Right? So now I'm in our catalog. I can click off of, I have to click off of that layer. Sometimes if you get frustrated and it just doesn't run, you might have to close our catalog. But I clicked off of that layer and went all the way back up to a different directory so that ArcGIS didn't think I was using it. All right, so the next thing that I have to do is run the tool called calculate field. Calculate field allows us to calculate the value in a different field. So for example, we could say census tracts. This is what we want to do. I'm going to show you what we want to do in the GUI and then actually do it. So we want to calculate the value of area, and we want it to be equal to shape area. Okay? That's what we want to have happen. We want it to run in Python. So we're going to change this to Python so that the expression, we actually need to change the expression because it's going to look a little different. Shape area, it's going to look like that. It's going to have exclamation points. Okay, so this is what we want to do. I'm going to go ahead and hit Tool Help, and copy the example here over to ArcGIS, over to here. So here we've got the calculate field. The in features are the same, so that's good. The field name is now going to, we need to copy that down here to be area. The expression that we want to use is quote, exclamation point, shape underscore area, like that. So that will calculate the area field into the area value. And we can just leave this the same, Python 9.3. In other words, it's telling ArcGIS that this is a Python snippet. Okay. All right, let's see if we can run this or if I have to close our catalog in order to run it. All right, looks like it ran just fine. So now if I go back into SPA, lab data, C-Tracks, and I look at the table, I now have the area field calculated or appended onto this shape area field. Okay, close this up. That's exactly what I wanted. Because after the overlay is done, it's going to update this shape area field. Okay, it's going to update that shape area field, but it will not update this field. So I'll know what the area of each census tract was before the intersection and then after the intersection. Because I'm going to run an intersection right now. So let's click off of SPA, hide it so that ArcGIS doesn't think we're using it, and then we're going to do the intersect tool. Intersect analysis tool help. I'm going to go down here, copy up intersect. And then okay, and then we're going to the in features will be different. So this is think about what we're doing here. So this is just C-Tracks. So we actually need our in features to be the C-Tracks and the watersheds. Then we'll need to put our intersect output. The rest of this we don't need. Right. So let's make a new variable called in feature. Well, in features is fine. It's going to overwrite that other one. That's fine though. So we've got C-Tracks. This has to be a list, remember? And then watershed. And then our intersect output, our intersect output can be equal to, I'm going to call it CW intersect. All right. And now I've got my intersection there. So now I'm going to try to run this again. Yep, this will work. Okay. Once this runs through, we can see what it looks like inside of ArcGIS. Did I spell something wrong? Watershed, C-Tracks. It's watersheds. Sorry about that. All right, so it finished. So now I can look at that in our catalog. If I go into SPA lab data, I'm gonna have to hit refresh. Looks like. So now I've got my CW intersect. Here's the intersected layer. So this intersected layer shows only the areas in common to both layers, and that's fine because I can only calculate population in those areas where they intersect. So I'm only looking for the amount of people that live in each watershed that are Mississippians, that live in Mississippi. Okay. All right, so if I look at the attribute table, notice that I have a field called area, and now I have this recalculated shape area field. That's exactly what I wanted. So I know that this census tract used to be this big, but now it's only this big. In other words, part of it got cut off, or either cut off entirely because it was outside of a watershed, or it's in a different watershed. In fact, if we sort these by the census tract number, you'll notice that sometimes there's duplicate. Like, let's see, these are the tract IDs. Yep. So right here, 02001, 02001, 02001. So these are three census tracts. Okay, they're the same census tract. And if we go over here, we can see that if we added these numbers up, they would equal this number. Okay. All right. And so on. So the shape area allows us to find out what percentage of each census tract lies within each HUC. Okay. All right, so let's finish this up. So the next thing that we need to do is calculate a new field called population, or let's call it adjusted population. At this time, I can just copy up the last add field. This time, though, we're going to add the field to the intersected output. And again, we'll leave it as a double. Ultimately, this is going to hold population. Oops, sorry. This goes here. And then the name of this is going to be adjusted, I'll just call it adjusted pop, the name of this field. It's going to hold a population value, but in order to not round until the end, we're going to make it a double, even though you can't have part of a person. Okay. So we're going to add a new field that's going to have the prorated population value. So in other words, what we're going to do is take the shape area, the new shape area, divided by the area, which will give us the percent of area that's in that watershed, and then we'll multiply that by the population value to get a number that represents the fraction of that census tract's population that lives within that watershed. Okay, so I'm going to do both of those at the same time. So I'm going to do two steps here instead of one. Okay. So I'm also going to copy the calculate field because we need to do that as well. And this formula will be a little bit more complex, but we're going to operate on this adjusted pop, same field. Okay. All right, and then we're going to that all is the same. We're going to adjust this formula. So remember, the formula has to be the population, which is P0010001. Okay. Oh, that should be an exclamation point. I made it a pipe. Okay. Times, I'm going to put this in parentheses. It needs to be the shape area divided by the area. Oh, and that needs to be in exclamation points because it's the name of a field. Okay. So what this is going to do is it's going to go down and it's going to first create this new adjusted pop field, and then it's going to put the values of this field multiplied by this ratio into it. Okay. All right. Before I run that, I need to click off, close it up, and go back over to here. Now I'm going to try to run it, and you'll see these population values Actually, before I run it, I'll make it a little bit bigger so you see the full line. Now I'll run it. And okay, it says it's being used by another window. I don't know why exactly that is, but I'm gonna have to close up our catalog before I run it. If you have that kind of error, just close up anything that you've opened. Sometimes ArcGIS hangs on to it for a few seconds. So I'm gonna run it again, and I am going to open up ArcMap to show you the result. And then I'm going to leave it to you to finish off the lab. There's one more command, and we'll talk about what that is when ArcMap up. So it ran through. Okay. And ArcMap should be opening up now. And we'll add that. So now I've got my CW intersect, okay, right here. If I open up the attribute table, here I have my adjusted population. So if I click on this line right here, you'll see that, okay, so that one's way up there. I'm going to click on a different one. I'll just actually highlight this one. I'll highlight one of the Lamar County watersheds, like that one right there. Okay. So if I scroll down and find this one, you'll see that the population was in this census tract was 6,370. Okay. However, let's look at that original census tract. Actually, maybe this will make more sense. Okay. So here's the census tracts, and this is the original census tract. However, only part of it appeared in this is a watershed boundary that basically bisected this census tract. So this census tract got bisected by a watershed boundary. See that? It's watershed boundary. So now this polygon has an area that is, this this number, whereas this census tract here, this census tract had an area of this amount. And so what we did was we took this number, divided it by that number, which is bigger. So in some cases, you'll get the same number, like right here, 3862, 3862. What does that mean? That means that the entire census tract was located within one watershed, because these two numbers, this number here, 4288 something and 4288 something, are the same. Okay, so you're only going to get a fraction in areas where a fraction of the watershed existed in that polygon. All right. Okay. So these numbers represent the amount of people living in each of these polygons. I'm going to say selection, clear selected features. What's the final step? Well, we need to take the number of people living in each polygon and group them by HUC8. What tool is used to do that sort of activity? Okay. Well, since I can't hear your responses, I'll have to answer, but think about it for a second. See if anybody gets the right answer before I reveal it. The right answer is dissolve. The dissolve tool is what we need to do. And I'm going to go ahead and run it inside of ArcGIS, and then you're going to run it in Python. So if I go under analysis tools and that's not under analysis tools. It's under, just a second. Dissolve, data management. It's under data management. Okay. All right. So I'm going to run it to show you how this would work. So the input feature has to be still the output of your intersection. And then your output feature class, you can save that as whatever you want. I'll put it in D temp SPA. Okay. And then you're going to call this you're going to call this final or something. I'll just call it final for now. Your dissolve field is going to be the HUC8. In other words, the field that you want to summarize on. And your statistics field is going to be your population, your adjusted population. And you want the sum, which will give you the total. So you need to figure out how to get this into syntax that looks like this. So you've got your dissolve. Okay. So follow this help to get this done. Now I'm going to hit OK. All right. So now I've got my original watersheds back, except for they don't extend outside of Mississippi. And I look at the attribute table and I see the sum of the adjusted population. I can even symbolize by that. Okay. So I can see which watersheds have the most people in them. So it's pretty obvious it was going to be the coast. Okay. But it's interesting that this watershed has a fair bit of people in it. Probably mostly people living in eastern Lamar County. And this watershed actually has less people in it, even though it runs through a lot of Hattiesburg. All right. So that's the end. That's the end of what I'm going to present today. So what your task is to add the dissolve down here, and then send that to me. There's no need to send me the table. I mean, sorry, the table or any of the files, because I can run it using my input files. So I'm going to go ahead and stop the broadcast because I can't answer questions, but if on the broadcast, but I can answer questions if you send them to me, and I will try to get back to you within a day or two. I'm not sure exactly what my internet situation will be in Gabon, but I'll try to get back to you in a day or two. Send me your script saying, hey, it's not running. What can you do? All right, so where are we going? Next time I present, which depends on when I get the internet again. It may not be for a little over a week. But next time I present, I'll send out an email when I make a presentation. We'll turn our script into a tool to run inside of our toolbox. That's what we'll do next week. So one of the powerful things is that we can add our scripts and create our own tools, so that we could create a tool for doing this process with any watersheds or any census tracts, or basically any polygons throughout the world. All right. So I'm going to stop the broadcast and I'll share that.